Hello everyone and welcome to this session on Learn Rust with Gyan. In this video, we will look at the second part of the third chapter in the Rust programming language book. The third chapter is also titled as Common Programming Concepts. In today's video, we will specifically be looking at the data types. So without further ado, let's get started. Let me share the chapter link with you. That is the third chapter, second part, data types. So every value in Rust is of a certain data type as mentioned here, which tells Rust compiler as to what kind of data is being specified. So it knows how to work with that data. So for example, if there is an integer variable that needs to be specified, we need to specify the data type as unsigned integer 32 bits or signed integer 32 bit based on the type of variable that we're defining. Now, as we have seen in the previous examples, it is not always necessary to define the type of the variable if we are fairly confident that the type of the variable is not controversial. For example, the variable 42 could represent either a string or it could be an integer. And in this case, definitely the type of the variable needs to be specified so the compiler knows what it is meant to be calculating. There are two types of data types that we'll be looking at in Rust. One is the scalar data type and the other is the compound data type. The scalar data type, as the name suggests, takes one single value. So let's directly start looking at the code. What is the scalar type of data type? There are four data types that fall under the scalar type: integers, floating point numbers, Boolean values, and characters. So let's start with the integer types. If you see here, I have declared a variable called var and assigned it the value 2. So this is an integer variable. Now, if I want to assign or annotate this particular variable with its data type, I can write let var1 colon the data type, that is I32, and I'll be assigning it the number 4. So I'm specifically mentioning here that this particular variable is an integer variable of 32 bits. Now this I indicates that it is a signed integer, right? So let me quickly share with you the list of integer types that is present in Rust. You can also find this under chapter 3. So you can see the length and the corresponding whether you have a signed version of it as well as an unsigned version for each of the lengths, right? So the signed version is represented with I and the unsigned version is represented by adding U. So here in this example, in this coded example, this particular value var1 is a signed integer variable. So let us see the result of this by running this on our terminal. The file that I have created for this is called dtypes.rs and I've created it under the bin directory. If you go inside the bin directory, you should be able to see the file dtypes.rs. Let me get out of this, get into the source, and then do cargo run. Now, if I do -- bin, I can choose a particular file that I would want to run. So I'm going to give dtypes. It's going to both compile and give me the result. So it says that the integer values are 2 and -4. Sorry, 2 and 4. And because this is a signed variable, I can also give it as -4. Let's see the answer now. As you can see that 2 and -4 are being printed. Let's take a look at the floating point variables now. So for the floating point variables, similar to integer variables, you have various sizes. You have 32 bits, you have 64 bits, etc. And the syntax remains the same. You use the let keyword and say, suppose I'm going to define a variable called float x and assigning the value of 2 to it. And I'm going to create another variable float y, which I'm annotating as a 32-bit float value. So I say f32, which is the data type itself. And let's say I'm going to assign this to be 3.62, right? Now by default, and if we do not annotate, it is 64-bit floating value. Let us print this and see the result. All right. Oh, sorry. So I got warnings that these variables are not being used because I didn't uncomment the print. So as you can see, the floating point values are being printed as 2 and 3.62. Let's take a look at the next scalar data type, that is Booleans. Booleans are generally used in conditional statements. So Booleans give us either a true or false result, and they are used in conditional statements to check if a particular condition is true or false in nature. Now I can define the Boolean variable same using the let keyword. If I want to annotate the Boolean variable, I can say let the name of my variable colon and then bool is equal to assign it to either true or false or lowercase. So let me uncomment the print here and print the Boolean value for both boolvar and boolvar1. As I'd already mentioned in my earlier videos, in order to print the result, we need to put the result, we need to put the statements under inside println, exclamation mark, open and close braces. To write the statement, we can use double inverted commas, and to print the actual variables, we need to use curly braces. So here the first variable, that is boolvar, will get printed, and the second variable will be printed in this place. Let's save this and run this and see the output. So you can see that true and false are being printed respectively. Boolvar is true and boolvar1 is false. Let us look at the last scalar data type, that is characters. Characters, yet again, are fairly simple in Rust, right? So if you see, let me declare this. So you can again declare a character as char var. This is the name of my variable, and I'm giving it a value of character A. Now, if I want to annotate, I need to put a colon and then write the keyword char, which is the data type. Now, an interesting thing about Rust is that the char type in Rust is 4 bytes in size. So because it represents a Unicode scalar value, it can represent a lot more than just ASCII, not just ABCD characters of 1, 2, 3, 4. It can also represent stuff like these emoticons, right? So I don't know how it will be printed on the terminal, but it's worth giving it a shot, right? So let's try this. I'm printing both char var, which should print A, and I'm trying to print the smiley char var 1. Let's see what it prints on the terminal. Oh, all right, great. It printed the smiley for us. Right. So you can see that the character values are A and smiley, both of which are being printed here. If you want to annotate the character value, we need to use the keyword char. You can look at more about the keywords on the chapter page as well, on the Rust programming language book page, which is linked in the description box below. I would suggest some reading material for this particular chapter, which is numeric operations. So on this chapter page, you'll see a lot of numeric operation examples that have been given using the operators that are there in Rust. And I would suggest that as a reading material for all of you all to follow up. Now let's take a look at the compound type, right? Right now we just saw the scalar data type. Now we have compound data types where we can store more than one data type together, right? I mean more than one value together. So the first type of compound data type is also known as tuples. If you're familiar with Python or languages like that, I'm sure you would have heard of tuple before. In a tuple, you can have more than one data type clubbing it together. So take a look at the syntax a little bit more closer over here because the syntax is important. So I use the keyword let to define my tuple, which I'm calling it as tup, my variable name. And then I'm annotating it with the 3 different types of values that I'll be putting it inside the tuple. So my tuple is going to have a signed integer, a 64-bit float, as well as a small unsigned integer, that is a small byte, right? So if you see here, for the signed integer, I have inputted the value 500, and then there is a float value, and then there is an unsigned integer value. Now this tuple, let's see if I can print the value of this tuple, right? The tuple is, all right. So let's see what it says, right? So I cannot print the value of the tuple directly. Over here, instead, I get an error that I have not formatted it properly. So what is the best way to print the elements of the tuple? You can see the syntax in the next line here, line number 6. Now here, if I want to print the individual elements of the tuple, I can assign each of these elements to different variables. Here I'm assigning to underscore x, underscore y, and underscore z, and then pick one of the individual elements or each of the individual elements to print. So here I'm just printing y, but let me print the x and z as well, right? Because why not? So now these three statements will print the value of the first, second, and the third elements of the tuple respectively. So here I have to create a new tuple and assign it to the tuple that I created if I want to take out the individual elements and print them. Let me comment out the rest of the code and just run this part of it. Now this file I have called it as compound.rs. So I will be running this file now. Again, I have created the file inside the bin folder. So if you see, there is a compound.rs here. Let me get back to source, say cargo run bin compound. So you can see that the value of x is 500, underscore y is 6.4, and underscore z is 1. Now, is this the only way to access the elements of the tuple? No. There is another way to access the element of the tuple, and that is this. So if you see the syntax starting from line 11, what I'm doing is I'm accessing the tuple elements as tup.0, tup.1, and tup.2, right? So this is another way similar to array indexes, right? You can get the values of the tuples or values of the individual elements of the tuples in this format. So here 500, 6.4, and 1, right? I'm extracting these values like this and then printing the elements of the tuple using the println. So let me run this for you. So you can see that the value of tuple elements again are extracted and printed. In this case, we don't need to annotate. Now let us look at the other compound and interesting data type that everybody likes, arrays. Of course, arrays are definitely one of my favorite data types as well. So, all right. So I'll just comment out this part. So I can look at the array. So if you have worked with any other programming language in Rust, arrays are pretty similar to that. So you can define an array by using by just creating your variable. So here my variable name is A, which is the array name, and I'm going to be defining the variable as array as 1, 2, 3, 4, 5. And then to access the array elements, the indexing starts with 0. So 1 stays at 0, then 2 is at index 1, 3 is at index 2, and so on, right? So to access the first element of the array, I need to print A of 0. So I'm going to access the first element of array and print it and show you. So you can see that the value of array, the first element, is 1. Excuse me. There is also another method to explicitly annotate the array and assign the variables to it. So here I'm creating an array called A1, and then I'm saying that this array will have 5 elements, please pay a close attention to the syntax here, right? So here there is a square bracket wherein I define the annotation as well as the size of the array. In this case, in the first case, I didn't define the size of the array, but in this case, I'm annotating and need to define the size of the array. So here I've defined the size of the array as 5, and the type of the array elements will be I32, which I'm defining right at the beginning. And over here, I am just going to be printing the. All right, so here, as you can see, there are only 5 elements in this array, right? And the last index that can be accessed is actually 4 because index starts from 0. Here I'm trying to access index 6. So it gives me an error that this particular operation will panic in runtime because the index is not approachable. The index doesn't exist. Index is out of bounds. So Rust already gives us, a panic that this statement will not execute. You can see how this makes your life super easy, right? That right away Rust throws you an error before even you are compiling, right? So this is very useful because you will avoid all of these kinds of errors which you are likely to make, while you're writing your code, etc. So since it's already given me an error, I'm not going to work with this. Let me show you another way to create an array. So here you can see that I'm creating another array. Let me just copy paste this. So are you able to guess what this statement will do? Okay, let me print this out for you. Maybe I'll print 2, 3 elements. So it will give you an idea. All right. So you can see that the result is 333, right? So this actually is an array where I'm saying that this array size will be 5 and all of the array elements will be 3. As you saw in the annotation here, it said that all of the 5 elements will be of type I32, right? That is signed integers, 32-bit integers. Similarly, in this declaration, it says that all of the array elements would be 3. So if you want to declare an array where all of the initial elements will be 0, you can just put 0 over here, right? So this is just really easy, an easy way to declare an array where all of the elements are the same. So here are some more examples that I had written to show the index out of bounds error, which you're already now familiar with, right? So let's go back to our page and take a look at, so as you have seen the tuple access, I've shown you the array. And as you already know, unlike a tuple, every element of an array must have the same type, right? And one of the important things to know is that arrays in Rust have a fixed length, like tuples, right? So the declaration you have already seen, and these are different examples. As you can see, if you have a fixed length array that you need to define, that's when you kind of, if you have a fixed length structure data type that you want to define, where you know that this is a great example actually, because here we know that the number of months are going to be fixed in 12. You will only be using one of these in your code. So here it would be useful to define an array. And the different types of array definitions I have shown you: accessing the array elements, zeroth index, first index. I've also shown you what happens when you try to access an invalid array element, right? It already shows you index out of bound. So here is where we come to an end on this particular topic of data types. Let us summarize this very quickly, right? Data type tells Rust as to what kind of data is being specified, right? So it knows to work with that data throughout the program logic. There are two data type subsets. One is scalar and one is compound. Scalar, you have 4 types again: integers, floating point numbers, booleans, and characters. We can annotate each of them using a colon, and post that we need to write the data type. You can take a look at the Rust language book to see what are the different data types that exist, right? Most commonly used ones for integers are I32 for signed and U32 for unsigned 32-bit. And then you have F64 for 64-bit floating numbers, F32 for 32-bit floating numbers. Then you have char for character ones, and then you have bool for boolean. Right? Then you have compound types, there are tuples and arrays. Then again, tuples are using the round brackets, you need to declare them. And then arrays, you use the square brackets to declare them. In Rust, you need to remember that arrays are always of fixed length size. So if you need to use a data type that is of fixed length and which will store the same type of data, you can use an array. But if you want to store different types of data, in a data structure which is of compound nature, there you can use tuples. So thank you everyone for watching this video, and I hope that you are able to learn Rust and progress now. And I hope that you stay with me on this journey with the rest of the concepts as well. If you have any doubts or any other recommendations, anything else that you've tried out, please feel free to put it on the comments. If you are interested in learning more and would like to see more such videos, I would request you to please like, subscribe, and share my video. Right. Thank you once again for watching this, and hope all of you have a great day ahead.